Here is a geometry puzzle that looks much harder than it actually is. This right triangle has side lengths A, B, and C. A circle fits perfectly inside. That is, it touches all the three sides. Can you find the radius of the circle? No trigonometry, no calculus. Just one clever observation. Pause here if you'd like to solve it yourself. Most people immediately think about the Pythagorean theorem. After all, this is a right triangle. But knowing that a square plus b square is equal to c square doesn't tell us anything about this little circle. So instead of looking at the sides, let's look at the area. Connect the center of the circle to each vertex. Suddenly, one triangle becomes 3. And here is the important part. Every radius meets its side at a right angle, which means every small triangle has exactly the same height. That height is the radius we are trying to find. The area of the large triangle is easy, half the base times the height. But it is also equal to the combined area of these 3 smaller triangles. Their bases are simply A, B, and C, while each height is R. Factor out the common term, we get A equals half times R times A plus B plus C. Since both expressions describe the same triangle, they must be equal. Notice what we just did? Instead of finding the radius, we found something connected to it, the area, and expressed it in 2 different ways. This is a technique that you will keep seeing in geometry. Now let's finish the algebra. Take our 2 expressions for the area and set them equal to each other. Cancel the 1/2s, and we get R equals AB divided by A plus B plus C. This is already correct, but because our triangle is a right triangle, we can simplify it even further. Multiply the numerator and denominator by A plus B minus C. Now use the Pythagorean theorem. The denominator simplifies beautifully, everything cancels, and we are left with R equals A plus B minus C divided by 2. A surprisingly simple answer. Let's test it on a 3, 4, 5 triangle. Plugging the values into our formula gives R equals 1, exactly the correct radius. I love this proof because the hardest part isn't the algebra, it's noticing the right perspective. And that is a pattern behind many of the most elegant geometry problems. Let me know what puzzle you would like to see next, and subscribe for more like this. I'll see you in the next one.